6. Wow, we've come a long way. So we're going to continue to theorem 7. We're going to continue with theorem 7. But before that, let us do a quick recap, okay? So we talked about theorem 1 and theorem 2. And this is the summary, okay? That is summary. And theorem 3, theorem 4. Okay? So theorem 4, we said that opposite angles, the sum of the opposite angles is 180. You can draw a circle. This is not drawn to scale. So you can draw a circle to scale and then C. So you have A, B, C, D. And C first. So that A plus C will be 180. So this is for a circular quadrilateral, and B plus D also equals 180 degrees. So you can see first. So just draw it to scale and then see whether that is true. Then we also tackle theorem 5 and 6. Theorem 3 and 4 and then theorem 5 and 6. So we talked about the equal chords subtending the same angle at the circumference, or equal chords subtending the same angles at the center. Okay, so that's theorem 6. Okay, before we continue to theorem 7, let us, there's another property, okay, from theorem 1. We saw that whenever we draw a circle and then an arc, so this is an arc, and this is the center. An arc can subtend an angle at the center, and at the same time subtend an angle at the circumference. And we said that the angle at the center is twice the angle at the circumference, okay? And we will also establish that, let's call this angle, say, A, and this angle B, and this angle C. And let's say this angle should be X. It has been established that when we add A to B and then B to C, so the sum of A and B and C, so the sum of A, B, and C, okay, will give us X, okay? So A plus B plus C is equal to X. It has been established, okay? So you can draw it to scale and then measure the angles and see. But this can also be proven, okay? You can prove that theoretically, but I don't want us to go into that. It's a little beyond the scope of this lesson. That's circle theorem. But in case you want that, you can send it to my mail requesting for the proof of this. Okay, but it's going to take much of our time, so we are going to continue. So please remember, A plus B plus C is X. So when you are given any of the angles, any of the 3 angles, you can find the other. Even if you are given 2 of the angles, you can find the other 2. Okay, for example, in a question like this, you are given the angle here to be, say, 30 degrees, and the angle here is okay, let's say the angle here is 110. You can find this angle and that angle, because you know that half of this will give us this angle. So this angle will therefore be 55 degrees. And I can find this because the sum of this angle, that angle, and this angle will give us 110. So I can say that A degrees plus 55 degrees plus 30 degrees must be equal to 110 degrees. Okay. So therefore A will be equal to A plus 85 degrees must be equal to 110 degrees. Okay. So A will be equal to 110 degrees minus 85 degrees. Okay. And this will be so A will therefore be equal to 25 degrees. That's it. So you are done. Okay. So before we go to theorem 7, we need to understand the properties of a tangent. Okay. So tangent. So what's a tangent? A tangent is just a line, okay, that touches a circle at only one point. So if and only if a line is able to touch, so let's say you have a point, say P, so and a line is able to touch the circle at just one point on the circumference, we say that line is a tangent. So line P, no, let me say AB. Line AB is a tangent of this circle. Okay, and this point is called a contact point. Okay, and it has been also established that whenever a tangent, okay, a tangent touches a circle at one point, it also has a property with a radius. So this is the center O. It has been established that the tangent always makes an angle of 90 degrees to the radius. So we call this the perpendicularity of tangent and radius of a circle. So it's always 90 degrees. It is always 90 degrees. So we can prove that. I can draw. So you can draw a circle, okay? So this is my circle, and this is let me draw a tangent. See, a point should be here. So I draw a tangent to the circle at this point. So you must start the circle at this point. Okay, and I draw the radius from the center to the point. Okay, so I draw this radius. So let me measure with the protractor to see whether this is true. Okay. So I think I made a mistake somewhere here. Let me draw another circle. Let me draw another circle here. So I choose this point. The line should touch the circle at just one point. So you need to make sure you are accurate as possible. I think this is okay. So then I draw a line from the center to the tangent. So now I can measure with a protractor. Wow, and it's true. Okay, the angle between them is 90 degrees. Okay, so this angle is 90 degrees. Indeed, the angle here is 90 degrees. So note that the angle between the tangent and the radius is always 90 degrees. Okay, and once you understand the properties of the tangent, you can go on to theorem 7. Okay, so in the next video, we look at the theorem 7. Okay.